So we started our statistics unit today, and what we were going to look at first is data organization and different ways that you can display data, because one of our main things that we want to do when we're looking at data is to be able to look at it and see a pattern so that we can analyze and interpret the results. And so one way that we can do this is by making what we call a frequency table. Sometimes this is called a frequency distribution. And this is where we break our data up into groups that you can call intervals, or some textbooks call it classes. And what we did today is we looked at how you can break up data into classes and the process of then turning that information into a frequency table and then turning it into a graph. Okay? So the first part was, how do you actually break this data up into the correct number of intervals and also intervals that are even? And so step number 1 says, decide on the number of classes to include in the frequency distribution. And again, this is just another word for the frequency table. The number of classes should be between 5 and 20. Typically, I have normally between 5 and 10. Otherwise, it can be difficult to detect any patterns. If you have too few intervals, it's hard to see a pattern. If you have too many, it's also hard to see a pattern. The only math we really had to do today dealt with step 2. We need to find the class width. And what that means is how big are our intervals going to be. And so what you do is you first find the range. And remember, that is your biggest value minus your smallest value. Okay? You're going to divide that by a number of classes that you want. And then the most important thing is that no matter what your answer is, you always round up to the next whole number. And that's going to let you know how big your classes are going to be. From there, we're going to start with the smallest data entry as the lower limit of the first class. And then we will add that class width to determine the rest of the lower limits. From there, we will then be able to find our upper limits of our intervals. If you go to the next page, it's easier to see this when you're actually working an example. Says the following sample data set lists the number of minutes, and it should be 49, internet subscribers spent on the internet during their most recent session. Construct a frequency distribution that has 7 classes. So this, I am telling you, I want you to break this into 7 groups. So what we're going to do is we're first going to find the class width by finding the range and dividing it by 7. Okay? Well, for the range, I need the largest value, which is 88, minus the smallest value, which happens to be 7. And I'm going to divide that answer by 7. And when I do 81 divided by 7, I get about 11.6. So I am going to want to use 12. Remember, you always round up. What that tells me is I want my intervals, or my classes, to each have 12 numbers in them. So what I'm going to do is I'm going to start with my smallest data value, which is 7. And I'm going to go through and I'm going to find all my lower limits first. And I do that by just adding 12. So my next one will be 19, then 31, then 43, then 55, 67, and 79. Now, the thing is you can't have 2 classes that have the same number in them. The classes can't overlap. And so that kind of helps you get started on the first upper limit. If the second one starts with 19, that means the first one had to end with 18. And then you can continue to add 12 and get the rest of the upper limits. And those are your intervals. Now, the tally column, what we're going to do is we're going to go each data value, and we're going to mark which class or which interval it's going to fall in. For example, 50, our first data value, will fall into this interval or this class. The next one is 40, and you go through and you mark your data values with tallies. And just to speed this process along, here are the amounts you should get for each class or each interval. The frequency is just where you write down how many tally marks you had. The first class had 5 marks. The second one had 10. then 13 marks, then 8 marks, 5 marks, 6 marks, and 2 marks. This symbol right here, this is the Greek letter sigma. And in math, what that stands for is it stands for the sum of. And so when you see that symbol, this is saying find the sum of the frequencies, which means to add this column up, and it should add up to 49. This is a frequency distribution or a frequency table. Now what we can do is, sometimes even this is not clear enough, we will make a special kind of bar graph that's called a frequency histogram. And if you look down here, here are some of the characteristics of a histogram. It is a bar graph that represents the frequency distribution of a data set. It has the following properties. The horizontal scale is quantitative and measures the data values. This is where you're going to put your intervals. The vertical scale measures the frequencies. And then the consecutive bars must touch. So if we go to the next page, let's make one for this data table that we just completed. Since our lowest data value was 7 and we didn't start at 0, I'm going to put a little jagged mark like so to let us know that we didn't actually start at 0. And then I need 7 intervals. 4, 5, 6, 7. Try to space them evenly. And this is where I'm going to write my classes or my intervals. Now these intervals, you should label the x-axis. These represent the number of minutes of each internet subscriber. We might want to put the title of this graph as internet usage, because that's really what the whole graph is representing. Now the frequency goes on the vertical axis. You really need to make the frequency table first so you know which interval or which class has the greatest frequency. From our data, the greatest frequency was 13, so I know I need to count up to at least 13 on my vertical axis. Count by an appropriate scale. 13 is not that big. We could count by 1s or by 2s. Either one is fine. I'm going to go ahead and count by 1s. And we know that we need to go up to at least 13. Okay. And then we're just going to create a bar graph where the consecutive bars are touching. For 7 through 18, we had 5 data values in that interval. In 19 through 30, we had 10 data values. Notice that this bar must touch the previous bar. The next group had 13 data values. And you just continue to go through and graph your bars like this. And this is your histogram. One option that you do have is if, for example, let's say you had to count by 5s or by 50s or by 1000s on the frequency axis, depending on the problem, one thing you may want to do, and it's completely optional, is you can write the actual frequency amount on the top of the bar in case you needed to work additional problems with those.